So before I talk about it, let me talk about L2, L3 trace flow. This is a new feature in NSX 6.2. If you guys attended the yesterday's session on operations, I talked about it earlier. What it does is it lets you inject an artificial packet, a custom crafted artificial packet into the source VNIC. The VM doesn't know that the packet has been injected. It's done through the NSX. The packet takes its natural course of the path, switching, routing, firewall, everything that needs to happen through the packet, and then it tries to reach the destination you specified. And while it goes through that particular process, you get observations from different points, like the firewall, the switching, the routing, all those things within NSX, and it will tell you that what was the path taken, if a packet was dropped, why it was dropped, if it was made through, why that packet made through the other side, right? So it gives you a nice view of doing that. However, what we are going to demonstrate in this particular demo, since it's a management pack demo, we will show you how can we call this through an API, because everything that you do through the UI in NSX is also an API. So you can always call that as an API. And in our case, what we are doing is the management pack is going to call the same API and get the result back to us and then show it in a nicer way. So let's just do that. Let's switch again back to the demo. Okay, so basically what I'm going to do here is, want to add something? Okay, so yeah, so this is the object path. So we saw the topology view earlier, which was like one VM, one object selected, and how it's connected to virtual and physical world, right? But now I want to basically do some kind of a search where, hey, why web VM cannot talk to app VM? Let me just do a search for web first. I click on it. Then let me scroll down a little bit, and then I don't know if you can see it, but it says select the second object for exploration. So what I'm going to do next is go down here, select the app, because that's the other VM that web cannot talk to. And what it's going to do here is build a topology map. So it's basically going to give, if there is a connectivity, if you have wired things correctly hop by hop, then you'll basically be able to build this path. I can see that the web to app has to go through a web zone logical switch, to a distributed logical router, to an app zone, and then to the application server. Let's also look at how things are wired in the physical. Yeah, it's still building this thing, so let me just refresh it, so to arrange it correctly. I may have to move the icons a little bit here and there. Let's see, okay. So if you look at it, the way it's connected is I have the web server running on my physical host .73, which connects to two top of the rack switches. So it's telling me how things are connected there. It connects to the spine switches, which are my Arista switches. Again, connects to another set of Arista switches, which is 7150s here, which are again leaf switches, to the destination host and to the VM. So now I'm basically able to draw a topology map between how things would flow on the physical world, right, from point A to point B. I can always look at, since we are polling for through SNMP on the physical side, I can always look at the health of the network, saying, hey, do I see any problem in the physical world? I can double click on that and see what could be the issue, and then triage that issue, right? So gives you a nice way of how things can flow from virtual and physical, right? Also, we talked about trace flow. So let me just see, if you think it's something that is blocked. I see that everything looks good, maybe some issues, but it should not block my connectivity. I need to troubleshoot further whether NSX configuration is blocking that communication. I can always, go into this, do the navigate thing again, and go to a troubleshooting tab, which is the fourth tab in the process here, and then I can actually go, say, run trace flow. So there's an action on the right hand side. You can see that. And I can click on this little arrow here, which says run action, and it will basically call the API. It takes some time, probably 30 seconds or more, to basically get the API call, because it's telling NSX is further going to execute that process and give you the report. We can wait for 30 seconds, or maybe I can just quickly show you how the reports may look like. In case of earlier I ran this particular trace flow, you'll basically see all the hops that were taken by the packet, right? So I can see that it was injected into the VNIC. Then from where it was injected, it was in the web SV01. Then it entered into the firewall, which is the VNIC level firewall on the NSX, called distributed firewall. when it exited the firewall rule 1028 allowed the traffic kind of, to go through the firewall. So I know which rule allowed it. Then it went into the web zone. As we know, it's connected to the web zone to the DLR, which is our distributed logical router, got routed there, forwarded to the other switch, which is a sales zone, and then, basically go on and so forth. So basically, you get the idea, right? Let me just see if the thing is completed. So yeah, this is basically what the earlier, the request that we made for the web and app. This is how it will look like. So, you see that the observation was dropped actually for some reason, and we can always investigate why it dropped. So you see the path here going from the web to the firewall to the web zone, DLR1, app zone. Then at hop number 7 and 8, it actually left the host. It was encapsulated in the VXLAN packet, made it to the other side where it was decapsulated. That's .100. Then the firewall policy, dropped the packet 1031. So that's the rule basically dropping it. So I can always go back to my firewall rule policy and see what's happening. The nice thing about vRops is it actually goes and pulls that 1031 firewall rule and shows you which firewall rule dropped it. So you have a view. You don't have to go into another screen to look at it. You just know which rule dropped it, right? So it's a nicer view. If it gets delivered, then it will not pull any rules because it made it through to the other end, right? So yeah.
This is another very key capability for troubleshooting. If you look at it, as you're seeing that virtual layer and the physical layer, you knowing where the problem is, whether it's a problem in the NSX layer or it's a problem in the physical. So if you take an example of the 7 and 8, if there was an issue with the physical, the packet would have never received the 8 hypervisor. So we would have at least told you that, okay, it was never received on the other hypervisors. That means you have to go and look at the physical network. So that is a very important capability to make sure that we provide you the right information for you to start troubleshooting more.
Right.
And in some cases, we will give you more information to just tell you where the problem is.
Right. So that's just a little animation of what we saw in the demo.